We have already dealt with factors in this year, yes? What are factors? What's a factor? Okay. Everybody can do it when I ask for examples. What are the factors of 25? There is 1 times 25 and 5 times 5, because both of them equal 25. So what are the factors of 25? 5, 1, and 25. So we all know what a factor looks like, yes? But a lot of people have trouble describing what it is. Right? Any two terms that multiply together are making factors. All right? We know this, yeah? So far this year, you have seen factors with numbers, and you have seen factors with polynomials. Right? Because that is 3 times that. And you've seen how to draw that. You make the rectangle, 1, 2, 3, x, 1, 2. You know how to deal with factors, yeah? All right, now, if it happens once in math, it always happens in math, two things multiplied together, they give you a product, yes? Which means the two things that multiplied originally are the factors, yeah? So what do I have here? Are those factors or products? That's a factor, right? Factor 1. And that is factor 2, because they multiply together, correct? Now, if I were to draw it, it would be 1, 2, 3, 4, and x and minus 5, right? And I would get 1, 2, 3, 4 x's and negative 20. Right? Okay. If we were going to do it algebraically, what would it look like? This is concrete, showing me what is actually happening. What is it algebraically? What would I do when faced with that? I would use distribution, which is 4 times x minus 4 times 5, which is 4x minus 20. Yeah? So this is my product. All right? Now, I'm not going to do that yet. What are these? Factors or a product? Factors. So I don't have a product yet, do I? So if it was the first day of polynomial multiplication, then we would draw 4 arrows here, wouldn't we? But I gave you a shortcut to help if it was just x and x. Does anybody remember that shortcut? If you don't, that's no big deal. Let's just distribute it out, and then we'll talk about that shortcut. First arrow, x times x, x squared. Second arrow, x times positive 2, plus 2x. New term, new line. 4 times x, positive 4x. 4 times 2, positive 8. Answer, x squared plus 6x plus 8. Now, seeing it written like that, can anybody remember the shortcut? 6, 4, and 2. 8, 4, and 2. Does anyone remember the shortcut now? Oh, that's hurtful. 4 times 2 is 8. 4 plus 2 is 6. If you have a single number there, x, then the next term is going to be plus if this is A and this is B, it's going to be A plus B with an X, and then A times B. Everyone remembers this, yeah? All right. Now, here's what you have to know. Factoring is the reverse, not inverse, reverse. All right? So, factor 12. We, this year, have factored 12 using a factor tree, yes? Right? 2 times 2 times 3. Okay? What then are the prime factors of 12? 2 and 3. And it's 2 squared times 3, correct? These are the prime factors. Now, another way that you were probably taught to factor when you were a kid was to find pairs of factors. Yes? And most of you were probably shown something that looked like this. 1, 12, because 1 times 12 is 12. And then 2 and 6, because 2 times 6 is 12. And then 3 times 4, because 3 times 4 is 12. This is the prime factors. This is all factors. Everybody cool? Has everybody seen this notation before? Seen something written out like that for factors of a number? Everybody? All right. Pardon me? It was what? What was in the test? This? Okay. I don't remember that being in the test. I remember prime fact. Oh, yeah. Right, that one multiple choice question. Yeah. Okay. So, we're not going to use algebra tiles, but we are going to do it as a picture. Now, remember, is that a product or is it factors? It's a product. Of course it's a product because there's no multiplication there, right? Now, if I'm going to draw a picture of that, since it's a product, where does it live in my rectangle? Inside here, yes? So somehow I have to make this fit in here. What is this made up of? There are 6 bars. And there are 3 little guys, yeah? How do I make these 2 fit in here? How can I draw 6 bars so it makes a rectangle? What are my options? I could have 2 and 3 or 1 and 6, correct? So I could either have 6 down this way or 6 this way, or 2 and 3, right? Okay. So those are my 2 choices. But in this rectangle, I also have to fit 3 little guys. And it has to make a rectangle. So if I go 6 bars down, can I catch up to that with only 3 boxes? No. All right, fine. So let's go 6 bars across. Can I catch up to that with only 3 boxes? No. So it must be the other way I write 6, which is what? Because 6 is 1 times 6 or 2 times 3. Now, can I catch up to that 3 with those 3? Yes. So I could draw this way. Is that 6? And then how many little boxes do I need to get in there? 3. 1, 2, 3. Does that make a rectangle? Can I go down and across, up and across, and make a nice toity rectangle? Yes, there's nobody sticking out the side, everything's cool. Now, if that is my rectangle, then what are my factors? Where do the factors live? On the edges. What is down this side? 1, 2, 3. What is down this side? X, X, and 1. So what are the factors of that? 3 times 2x, that's supposed to be green. 2x plus 1. And what will that equal? 6x plus 3. Is everybody cool? Now, of course, just like before, this can be done with algebra. All right? I started with 6x plus 3. Yeah? What did I do with the 6? What math did I perform? How did I get to these factors? I divided it into different shapes, yes? So I was able to divide 6. I could have divided 6 by, would I ever use 1? No, because 1's everybody's factor, right? So I could have divided 6 by 2. I could have divided 6 by 3. And I could have divided 6 by 6, right? What can I divide 3 by? I would never use 1. I can only divide 3 by 3, yes? Now, since this is a binomial, that means they're stuck together. What's the only one of those 3 that works for both of them? 3, which makes 3 my GCF, which we have already talked about this year, right? So I can also do this with algebra. I can take my original polynomial, divide it by the common factor, which gets me 2x plus 1, because 6x divided by 3. That gets me one factor, and my other factor is 3. And if you look back here at what we just did, didn't we take 6x plus 3 and divide it into 1, 2, 3? Is everybody cool? All right. Turn the page over. Let's look at the next one. What am I starting with? I got 4x squareds, right? I could draw them like that, couldn't I? Or vertically, yes? What's the other way I could draw them? 2 by 2. Agreed? What is the only ways I can draw 6x? We've already done 6x. What are the ways I could draw it? I can draw 6, 5, 6, 5 and 6 because I'm out of space. Or I can go which one works together? The 2 and the 2, yeah? Oh, those should have been boxes, you moron. You're all seeing me try to erase this, right? This isn't just happening in the matrix. It's really happening, right? You're watching me do this. Okay, just making sure. Now, does this way work with this? There's 2 rows, aren't they? But if I try to make a rectangle, this is long and that's short, isn't it? So I can't do it this way. What must I do? If I turn these, how? If I turn these now does it work? Because now, son of a motherless goat. Still no erasing. Now, I've got the same width, don't I? Except, what happens if I do this? Okay, Myers, I got you. You're not fooling me. There. Same width. And there. Same width, right? So there's my rectangle. Or is it? It's not, because it's going to make a weird shape, isn't it? That's not a rectangle. So what would I need to do? 3 on the top, 3 on the bottom. Now I can make a rectangle, can I? So what do I got? What's up here? What's that? X. What's that? What's that? What's that? What's that? So my first factor is what? How many x's do I have? 2 x's. And what have I got there? Plus 3. What have I got down here? 2x. There's my other factor. 4x squared plus 6x. Yeah? And, of course, I can do it with algebra. 4x squared minus 6x. Out of that 4, I can take 1, 2, or 4, yes? Out of the 6, I can take 1, 2, or 3, or 6, yes? What's the only one that's common? 2. Out of that x squared, I can take how many maximum x's? I could take 2 from there, but this guy can only give 1. So I can only divide by 1x. That becomes one factor, and this answer becomes the second factor. Yeah? Is everybody good to there? I don't want to melt your brain. That is where we stop. We are not going to talk about this one until tomorrow. Everybody cool? Now it's going to get a little weird here because we're going to be all over the map. Go to page 127. And what does it say? Factoring polynomials, number 1. The greatest common factor. This is what we just drew. All right? What we drew. Now, we're not going to be spending a lot of time drawing. Here's why. The drawing doesn't work with any exponent larger than what? Anything larger than squared, I can't draw it, can I? Because larger than squared, I need to draw a cube. And that's real hard to do on a piece of paper, right? So that's why I used the drawing to show you what was happening. But you can only use the drawing if your exponents are less than 2. Are there numbers bigger than 2?
Yes.
Yes. So is there a chance our exponents will be bigger than 2? Yes. So we better know how to do this with numbers bigger than 2. But if we know how to do it with numbers bigger than 2, is it going to be the same all the way along? Yes, because if it happens once in math, it always happens, right? So there's a couple of rules about greatest common factoring, which I, of course, abbreviate to, and this is a weird thing, I abbreviate it to GCF factoring, which means greatest common factor factoring. You say it twice, okay? The thing you have to remember about GCF, and I'm going to write it in green, and I'm going to write it in very thick green pen, always try this first. If you can do this, do it. Okay? Always. Because this will simplify things for you. And who doesn't want their math simpler? I know I do, right? So, here's what you do. We're going to start real easy like. What if I gave you 10, 10. And I ask you to factor that. Now remember, up to this point this year, we've been looking for prime factors, yes? Now we're looking for groups of factors. What are the factors of 10? 1, 2, 5, 10. Agreed? Okay. What if I added then x cubed? I could take out 1x, 2x's, or 3x's, yes? Everyone cool? Because I can divide out of that up to a maximum of 3x's, right? Okay. Then I give you this. 22. What are the factors of 22? 1, 2, 11, 22. Agreed? And I then say that's x. What's the maximum amount of x's I can get out of there? 1x. So everybody knows how to do this, yes? I could list a bunch of numbers and we could do this for them, right? The only difference now is instead of being all separate things like it was in grade 5, it looks like this. So, all we did was we found our factors here, we found our factors here, but now they're put together. They're all in one thing. So I must need a factor that works with both of them. What is it? 2, because you can see 2 is in both. I just gave it away, the next one. And what else is in both? A single x. Yeah? So what is our answer? This is where it gets tricky because this is where people screw it up. All of you see what math this is. What is it? What's 10 divided by 2? 5. What's x cubed divided by x? X squared. What's 22 divided by 2? 11. What's x divided by x? Nothing. All of you see that, right? But you will forget that there's also a 2x. Because at the end, you have to be able to make this. Everybody cool? Now, that's what's actually happening. You guys, for whatever reason, like to have a nice list of steps. You know I hate those lists of steps, but I will provide it for you. To GCF, factor. Step 1, find the GCF of all terms. How do I find the GCF? We've done that already, right? If you don't see it automatically, you got to make your factor tree and find it, right? Can you forget about variables? No. You got to remember that you are looking at coefficients and variables. Step 2, what was step 2? Once we had our GCF, what did we do with it? Divide all terms by the GCF. And step 3, write your answer as such. Your answer in this form. GCF, bracket, and then, what's the answer in a division question called? Does anybody know the word? Quotient. You write it as GCF, and then quotient 1 plus or minus quotient 2 until when? You run out of quotients. Quotient n. Okay? Here is what it looks like in actual use. Now, what is actually happening we did, right? Is everybody cool with what we did? So can I slide over to use the checklist? Because that's what you guys like to use anyway. You've seen what's actually happening. Here's the checklist. Step 1, what is the GCF? GCF equals 5. Why is it only 5 and not 5x? Because there's only one x. So step 1 was find our GCF. Did we find it? Yes. What is step 2? Divide all the terms by my GCF. So 5x plus 5, everything needs to divide by 5. Everyone agree? And step 3, write the answer out in the right form, which is GCF. What was our GCF? 5. What is quotient 1? What's that division? X plus, what's quotient 2? 1. And then we're out of quotients, so we stop. How do you know you did it right? You take 1 second to check at the end, which none of you will do on your test, and you will all lose a ton of marks because you refuse to take a second to check. Is 5 times x 5x?
Yes.
Is 5 times 1 5?
Yes.
So are we right?
Yes.
Yes. Everybody good? All right. Do the next one. It looks exactly the same. So the rules are the same. Step 1, find the GCF. What is it?
3.
Step 2, what is it? Divide by the GCF. 6x plus 3 divided by 3 divided by 3. And last step, GCF first. 3. What is the first quotient? 2x. What is the second quotient? Do I have any more quotients? So I stop. Next one has 3 terms. Does anything change? What's the GCF?
3.
GCF equals 3. What's step 2? Write it out and divide everything by the GCF. 3, 3, 3. Then I answer. GCF first. What's the first quotient? X squared. What's the second quotient? Minus 4x. What's the third quotient? Minus 2. Do I have any more quotients? So I stop. Negative 12. So it has to be negative 4. Because 12 divided by 3 is 4. Yes, Tommy. Oh, I wrote it wrong. Sorry. Plus 4. I just wrote it wrong. And now the last one's slightly trickier. How? What's trickier about the last one? There's a variable that I have to care about, right? So everybody sees that this is obviously 2 and 2. But how many x's are there? 2. How many x's are there?
1.
So that means I can get an x out of there, can't I? So what is my GCF here? 2x, and then what's quotient 1? 2x. 4 divided by 2 is 2. X squared divided by x is x. Plus, what is quotient 2? 3. No x. X divided by x cancels. Is everybody good? Yeah? All right, I'm going to be mean, and I'm going to give you one to try on your own, and then I'm going to shut up. Does anything change? Of course not. What's the GCF? 8. How many x's? How many x's? 1. How many y's? 1. And then I just write my answer. The hard part is finding the GCF. I'm not even going to bother writing the answer because everybody should be able to do it, right? Okay, let's do these 4 together, and then I'm going to give you work time. While you are working, I'm going to come around and get your score out of 8. Okay? So we're going to work these together. Who would like to offer me the number part of this GCF? What is it? 5. Who would like to offer me the variable part? Holly. X. Holly, why is it only X? I can quite plainly see there are Y's everywhere here. 15 is the one place that there isn't a Y. But there's squared and squared. How come I only need 1x? Because 25 only has 1x to give. Then I write it out. GCF first, 5x, and then all my quotients. 25 divided by 5, and you just did a unit on exponents, right? So this should be about that fast, yeah? 25 divided by 5? 5. X over x? Gone. What's left? Y. Plus 15 divided by 5? 3. X squared divided by x? X. 30 divided by 5? 6. X squared divided by x? X. Y squared divided by? Y squared. Yeah, that's going to be the answer because it's divided by 1. Is that technically written in the right order? No. But was the original question written in the right order? No. What should have been first? 15x squared. Alphabet first, highest degree. So this is why I don't care about order, right? If you hand me this, you're getting the full marks. Okay? Everybody good? Okay, what's the next one? What's my GCF? 2. Do I need to write 2, 2, 2, or can I just write 2? As long as I know what I'm doing, right? I've been doing this longer than you people have been alive. Do you think I write 2, 2, 2? No, I only write the 1, 2. What should you do? Whatever you're comfortable with. So that is 2 out front, and what's the first quotient? 4. Plus what's the second quotient? 5a. Plus what's the third quotient? 3a squared. Done. Now, C is tricky. What makes C weird? There's C and D, and there's negatives all over the place, yes? And I know negatives, the only thing that scares you people more than fractions are negatives. So, this is where you got to remember something. What is the greatest common factor here? 5. You want to divide by 5CD, correct? Is it only 5CD, or is there any exponents involved? Why are there no exponents involved, Hannah? Because 25 only has 1 C and 1 D to give. Everybody cool? All right, so let's draw this out. My GCF's going out here, yes? Okay. So what's my first quotient going to be? Negative 4C3. What's my second quotient going to be? Negative 6C squared D, right? And my third? Negative 5. This is technically right because this is our greatest common factor, yes? But notice, what do you see there? 3 negatives. We like to get that negative out of there as well. So it isn't the greatest common factor, is it? Because negative 5 is lower than 5, yeah? But we still like to get, if a negative's in there, we like to get it out. So that means we would technically take out a negative here as well. So what would this be? Negative 5CD. And what would that do to all these signs? 4C cubed plus 6C squared D plus 5. Does everybody see? We just like to get the negatives all the way out. That way, if we're going further, we're only dealing with one negative instead of three. Does everyone understand?
Yes.
It's a very powerful tool to use later in math because this negative 4c squared minus 6c is the same as negative 1 times 4c squared plus 6c. Everybody cool? All right. And D. Can I do anything with D? Why not? 2 and 3 only share 1 as a factor. We never use 1. And X and Y are different. Why would I put that question there if I can't do anything with it? So you can see, if there's nothing to be done, what do you do? Nothing. You don't force math where there is no math to be done. Okay? Is everybody good? All right. Now, when you turn the page over, you're going to see the word assignment. I do not want to stress you out because that is how important this is. You will get lots of factoring practice later in this unit. So I'm just going to say this is work to be done. Now, I cannot stress this enough. I know it seems easy. Practice it until it is so easy that you can do this step without writing it down. Do you understand what I am saying? Do you think if I was doing a question like this and I knew there was further work that I would even bother writing this step? No. I see this line right away. Am I smarter than you? No. Have I practiced more than you? Yes. Just like I can juggle and some of you can't. It's not because you don't have two hands and two eyes. It's because I have practiced juggling in a stupid attempt to make myself interesting to girls at university.
Wow.
I also learned how to make balloon animals. Both failed miserably. True story. Mind you, I can make a poodle hugging a heart out of balloons. And a swan, and a parrot in a swing, and a sword, and an airplane, and a daisy, and a mouse, and a giraffe, and a moose. And that's about it. I, however, will never give you a balloon animal because I think balloons are evil. Why are balloons evil? Not because of Pennywise the clown. Because they are garbage. And every single balloon ever popped is a small piece of rubber plastic that will never, ever, ever disintegrate. So for that 1 second that you're happy that you have a balloon, yay! There is 450,000 years of a tiny bit of environmental destruction from it. Which is why my poor children never get to have water balloon fights. They get so mad at me. Dad, it's so awkward. We have a water balloon fight. You have to pick up every piece of balloon. Okay. They never do. That's why I'm no fun in summer. Of course I am fun in summer because I do things like go out in my front yard with a tarp, cover the whole front yard with a tarp because I don't care about the lawn, put a bunch of dish soap and water on it, and then you got a 2,000 square foot slip and slide. You can slide diagonally, you can slide forward, backwards, you can try to cross in the middle and not smash into each other. Good times. I know it's lit. Big tarp. 50 by 40. I do a lot of camping, and nobody else brings a tarp, but everybody hates rain. So I got to have tarps big enough to cover all my friends.